Today we're looking at multiplying and dividing with exponents. We've already done a bit of a review of just how exponents work in general. Now we're going to look at some rules. We're going to call them exponent laws, or rules, I guess. I'll use either term interchangeably. That's going to help us. That's going to help us just simplify exponents and make our life a lot easier if we learn them. Now, some people, in my experience, they don't learn them and then they really struggle because there's a lot of stuff we do with powers and exponents in this course and in future courses. So I really want to encourage you to take the time with this lesson and review it as much as you need to until you really know and feel comfortable with the rules we're going to show in this lesson. So jumping in, any value or variable without a visible exponent is understood to have 1 for an exponent. So for example, 3 means 3 to the 1. That means the same thing. If you see a variable like x, it means the same thing as x to the exponent 1. Even this part, 2y, I can think of there's an exponent 1 on each and every part of this one, so it's 2 to the 1 and y to the 1. So anytime you don't see an exponent, you don't have to write it in, but you just need to understand that we could think of it as if it did have an exponent, because that'll come in handy later. There's special rules for exponents when you multiply or divide with the same base. Now that's really, really important, the same base idea. It has to be the exact same base in order for this to be true. If we have a different base, why isn't it not giving me a nice circle like there we go. Just trying to get a bunch of nice, beautiful circles around the same base. There we go. All right, so if it's the same base, as in the same number in each case. So here's our first multiplication rule. Actually, sorry, I see the box for putting it in there, but let's just go through the chart first. All right, so if we multiply 3, what do I want to use to represent my same base? I guess I'll use the highlighter yellow. So if I have 3 to the exponent 1, and I multiply that times 3 to the exponent 2, then this 1 just means I'm going to multiply, that just means I'm going to multiply 3 by itself one time, or just I'm going to have a 3. I'm going to have a single 3. Let's think of it that way. If I have 3 squared, that means 3 times 3. Just trying to work out my highlighting system I want to go with here. So let's go with that. So 3 to the 1 just equals 3, and 3 squared equals 3 times 3. But I'm multiplying it all together. So if I multiply that all together, that's the same as 3 times 3 times 3, because the 3 in brackets up front is just multiplied as well. So I'm just multiplying 3 3's together. Well, 3 3's multiplied together equals 3 to the 3. If I had 3 to the 2, that means 3 times 3. And if I had another 3 to the 2, that means another 3 times 3. But that's 3 times 3 times 3 times 3, 4 times. And so that gives me 3 to the 4, right? So look at the exponents we're getting. If I do the next one, 3 to the 3 would just mean 3 times 3 times 3, because we know that powers mean multiply something, the base by itself, that many times. So 3 3's. And then I've got another 2 3's. And if I multiply them all together like that, we know that we could simplify that as 3 to the exponent 5, because there's 1, 2, 3, 4, 5 3's all being multiplied together. So if I want to do this without expanding it out, here's a shortcut. If I take 1 plus 2, that equals 3. If I take 2 plus 2, that equals 4, and so on. 3 plus 2 equals 5. So what we're going to see is that in general, if we multiply with the same base, multiply powers with the same base, what we do is we add the exponents together. So here's the actual rule as a formula. So I'm going to let A be my base, so the letter A, so that could represent any number, positive or negative number. As long as I have the same base repeatedly, then then everything will work out. So if I have A to some exponent, I'm going to call that exponent M, times A to some other exponent, again, same base, but I'll call this other exponent N, then what we saw is the shortcut is to rewrite as a single power, but now the exponent is going to be whatever M plus N is equal to. And again, A is just some number. It could be 2 or 3 or 10 or negative 5 or 21 or whatever. M and N are both numbers as well, but we just add M and N together. So let's use this exponent rule to see how it works. In the first example here, what you'll notice is they both have the same base. But they've got, 3 on one exponent, 4 on the other. 3 is like my M, and I'm going to give a little legend here. So M is going to be highlighted in green, N is going to be highlighted in blue, the base is going to be highlighted in yellow. But we know that if they have the same base, then I keep the base and then I add M plus N together. And that can be simplified to 2 to the 7. So that would be my answer for that one. For the next one, the base is 4, M is 5, N is 6. So I write that base again one time only, add M and N together, and that comes up to 4 to the 11. In this case, we have a variable for the base. That doesn't matter, as long as it's the same base as it is in each case. Then I can add the exponents together. And again, I'm thinking of 4 like it's M and 8 like it's N, and that becomes x to the 12. So when you know this rule, it's super easy to use. So easy, right? That was for multiplying. So keep this mantra in your mind. Repeat this to yourself as many times as you need to. Multiplying powers, or when multiplying powers, add the exponents. When multiplying powers, add the exponents. Now, if we go to division, we're going to see that there's a parallel rule. And you might even be able to guess what it is. If when we multiply powers, we add the exponents, what would you predict we need to do if we're dividing powers? Well, you might have an idea. Let's see. If I have 3 to the 2, which is 3 times 3, and I divide it by 3 to the 1, which is just 3, then the 3's cancel out. Like 1 3 on the top will cancel with 1 3 on the bottom. It just leaves me with 3 to the 1. All right, let's take a look at the next one. If I have 3 to the 4, that's 3 times 3 times 3, divided by 3 to the 2, that's 3 to the 2. Then again, 1 3 on the top will cancel with 1 3 on the bottom. And since there's 2 3's on the bottom, then 2 3's on the top cancel out. I'm left with 3 times 3, which is 3 to the 2. Well, did you figure out what the rule was? If I have the same base, again, it has to be the same base, then if I take 2 minus 1, I get the exponent on this one. If I take 4 minus 2, I got the exponent on this one. And that's always going to happen. When you divide powers with the same base, you subtract. Subtract has an A in it, doesn't it? The exponent's leaving the same base. So using the same style as I wrote up above, if A is my base, whatever it is, and I've got an M, and I divide it by some power with the same base, and I call it exponent N, then I can combine them into a single power where I subtract the exponents from each other. So let's look at an example of this. Okay, we got 2 of the same base. There's 6. We see it's division. Again, there's my M, there's my N. So it's going to be the same as 6 to the, that should have been in blue, shouldn't it? 6 to the 8 minus 3 gives me 6 to the 5. My base in this case is the negative 2. Here's my m, here's my n. So this is just a division. It looks like a fraction, but it's still just fractions that can be thought of as division, right? So exact same rules. So my base is negative 2, and m minus n is going to be 6 minus 4. So that gives me negative 2 to the 2. Again, this one's written as a fraction, but it's got the same base on the top and the bottom. 15 is m, 8 is n. It doesn't matter that it's a variable for the base. It wouldn't matter if there's a variable in the exponent for that matter. We could just add or subtract variables in the exponent too using these rules if we needed to. K equals 7 in this case. All right, again, you got to know these rules. These should be easy. These two rules I just covered should be easy to memorize. Multiplying powers means add exponents. Dividing powers means subtract exponents. I'm not going to lie though, we can add more and more stuff on where it could get confusing. So you want to really hammer down your knowledge of what we just did so that you're ready to move on to the next idea. So the first thing, and I think it's the only thing left for today, although we're going to see things in other days, the first thing is combining the rules. So as soon as we start combining the rules, things get a little bit trickier. So work with the terms that have the same base to simplify. For example, 2 to the 4 times 5 to the 3 times 5 to the 5 divided by 5 to the 7 and also divided by 2. So this time I'm going to use my highlighter to identify which powers have the same base. So 2 to the 4 and 2 have the same base. 5 to the 3, 5 to the 5, and 5 to the 7 also have the same base. So I'm going to rewrite this as, just refining my highlighter use as I go along. So these ones have the same base, but I'm going to still use this for m and n. So on the 2's, my m, again, m is going to be in green, just like I did above, and n is going to be in blue. My m is the 4. I'm dividing 2 to the 4 by 2 to the what? Well, there's no exponent on there. So you need to remember, if there's no exponent, it's always assumed to be 1. So there is an exponent, which I can think of it like it's an exponent if I write this as 2 to the 4 minus 1. So I combined, it's a single base, it's m and it's n, and that's only part of my answer though. So I need to pick another color for my other base. So let's go with orange. So I've got 5, I got a 5, I got a 5, and now there's a couple things going on. So maybe, how do I want to explain this? I could do it all at once, or I could do it in stages. I'm going to do it in stages for now, and then I'll talk about how I could do it all at once later. So if I do it in stages, that means I'm not going to do anything with the bottom one for now. So I'm going to leave that 5 to the 7 on the bottom. And so, but for the top, my m will be 3, and my n will be 5. So for those ones, I'm multiplying those ones together. So I would have 5 to the 3 plus 5. So I don't know if I mentioned it as I was thinking about other things. I may not have talked about the fact that when I did the 2, look back at the 2, I did 4 minus 1. That's because I was dealing with the 2 to the 4 on the top, and that 2 to the 1 on the bottom was a division. Because it's on the bottom, it's division. So again, divide means subtract. That's why this was a subtract. But for the 5's, I'm only dealing with the 2 that are on the top, 5 to the 3 and 5 to the 5. Those are multiplied together. And since they're multiplied, that's why that's a plus. once I deal with this 5 to the 7 on the bottom, then yes, it's going to become a divide, but that's what I was just debating whether I want to do it in one stage or 2 stages. So I'm going to simplify. I've got 2 to the 3 times 5 to the 8 over 5 to the 7 still. All right, I still have, because I did in 2 stages, I still have something I have to do. I have to divide 5 to the 8 by 5 to the 7. So for this part, I'm going to think of the 8 as the m and the 7 as the n. Nothing's happening to the 2 to the 3, so I'll just write that down again. But as far as the 5s go, I've got 5 to the 8 minus 7. So highlighting the part I'm working on. And then simplify, I've got 2 to the 3 times 5 to the 1. And that's simplified as far as I can go with the powers, with the exponent laws. Now, I could leave it like that, or I could keep going, depending on what the wording asks me. This one's a little unclear. Does it want me to stop with just a simplified power like that? Or I could keep going. So I just draw that line as a possible stopping place. But if I kept going, then I could say, okay, well, 2 to the 3 just equals 8, and 5 to the 1 just equals 5, and 8 times 5 equals 40. That's another possible stopping place. So again, I'll try to make the wording on my questions clearer when I do a quiz or assignment or something. But in this case, this is the main idea of what we're doing today, just to simplify using powers. The last part is just a little bit of a going further to change it to numbers. And that was the last example for this